And so two other elements that were brought in relatively recently, I think also with a version 1 release, a couple of navigational additions for the UI. One is that for some of these batch functions where we would have deletes or resets or zeros, the UI now supports control clicks, where you can choose non-contiguous sensors to do some sort of a batch function. So we could zero a sensor, but we selected these 3 sensors, we would see those zeroed and the others not. So let's go ahead and do that. Or shift-click in the traditional Windows paradigm, where it'll select everything from the first click, shift to the bottom click. And then there's also another feature here. That's up here, isn't it? Yeah, it is. Okay, this button on the upper right says hide and show FBGs. So we spent quite a bit of time establishing our FBGs and establishing the bins, but once those values are all established and you really just want to monitor the current status or the alarm status of all of your sensors, you can increase the real estate of the UI by clicking this upper right-hand button to hide and show the FBGs. Okay, this next bullet point is really a couple of thoughts into one, so we'll treat them individually. I'll do the first because I understand it, and let Dan explain the second part. FBG renaming propagation. So we have used all of these automatically generated FBG names as the variables in our sensor expression. But if you want to have a little bit more intuitive understanding, perhaps, of what these sensors are, then you can name them something specific. Here I'm going to call this particular FBG the black mounted, because it's in my office here. It's mounted on a piece of black metal, so that's something that I can visually recognize, and I'm going to assign that as its variable name. And now, if I click on that FBG, it'll show me which of these expressions use that FBG. And in particular, if I click on the OS3600, if I click on the OS4100, which actually references that FBG, you'll see that FBG name change was propagated through all of the expressions that use it. And so you're always free to use the automatic naming conventions or to give specific and unique IDs to your FBGs or sensor elements. And then you're free to change those at any time, and they both upward and downward propagate into the appropriate places where they're used throughout the system.
And that works for both FBGs as well as sensors. So if you renamed sensor OS4100_WebEx, it would be updated in the sensors that reference it. And all of the changes are made while the system is operational, and I'd say 99.9% of the time you can do this without any impact on your data acquisition. No errors will occur, and everything will continue to move along.
So where we left off was FBG renaming, and what we were going to demonstrate was when we changed the OS4100 name, that would also be changed in the OS3100 reference to it. I think that concept is clear enough, so without spending any more time on that, we'll move to the second part of this bullet, which is if you delete an FBG and then recreate that FBG with the same name, it will feed back into the existing sensor expressions. And Dan brought this up because it's something that you've seen in an application, and so a modification was made to Nlight to support that. Is that correct?
Yeah. So if you want to do an example, you can delete.
So it's the OS 4100 or 4300 FBG D1. So we can go ahead and delete that sensor. Thank you. Delete that FBG, which renders our OS 4300 sensor non-functional, as there is no source for it. And so now we can then recreate that particular sensor, range of 1510 to And if we give it the same name of FBG underscore D1 and give it a distance, it's going to require a distance of us since we are at non-zero distance on the other FBG, 4023. Okay, so then it's reinserted into that same expression and the calculations continue.
A relatively new feature in 1.0 is when you add FBGs in after you've created others, it will add them in ascending wavelength order. Now, obviously, it doesn't know, given what name you've created for it, it can't alphabetize it necessarily, but it will ensure that the wavelength of the detected peak is in order with the rest of the peaks. So here, D1 was inserted above D2.
Okay.
Another thing I'd like to point out there while Todd moves back to the PowerPoint is that the auto create button is also a synchronized button. So if you add new sensors, the auto create button can be used to go and find the new sensors, the new FBGs, and fit them in without modifying the bins for your existing FBGs. So by doing auto create after you have existing FBGs, all of the existing ones will remain and will not be modified unless they have to have their bins moved just slightly to make room to add the new one. But it tries as hard as it can to not modify anything that you've set up and created unless it absolutely has to get the new FBG in.
Okay. Looking back at our PowerPoint, let's see, we have a comment on when to average FBGs or sensors. Maybe that's better discussed after our next bullet, which is adding a sensor and independent sensor zeroing. So this is also a feature that was introduced with the version 1.0, and that is essentially that sensors can be zeroed independently of one another even if they have common computational elements or FBGs. So this becomes very useful when if you have some strain sensors already deployed in your measurement system that reference a particular relative temperature sensor for temperature compensation. And some time passes and maybe the average ambient temperature changes, but because of the expression, then that thermal component of strain is being effectively tracked for each of those sensors by that one common temperature compensation sensor. If at a later point in time you want to add an additional strain sensor, and you want to use that same common temperature compensation sensor, ideally what you would like to be able to do is at that later point in time add that sensor and zero that new sensor without having that zeroing operation affect your zero point for any of the other sensors, strain sensors, that use that common temperature sensing element.
In the past, and as we alluded to earlier with the configuration files, and the reason of the breaking change was previously we had a referenced mode on FBGs which tied a reference value to that FBG. Any sensor that was using that to compute its value would see that reference value, excuse me. So if you re-zeroed the FBG, all of the sensors using it and its expression would be affected. So if you had 3 strain gauges being temperature compensated by a single OS 4100, and you had zeroed them, say, 3 months ago, and then you needed to add a couple more strain gauges to your structure after seeing what was happening with the structure, over the monitoring of the system, you'd come back, install those new strain gauges, come into Nlight, and reference that FBG in reference mode, but it would show an offset. So you would have to re-zero the FBG in previous versions in order to reference the new strain gauge. What we've done now is made that referencing independent of the FBG such that each sensor that you create holds its own reference values for each of the FBGs and sensors that it uses to compute its value. So now, say you set up your system, you zero everything, 3 months later you add an FBG, you can use you add a strain gauge, you can use the existing temperature compensation FPG and you can zero the new strain gauges without affecting the previous gauges using that compensation element.
And that's something we will demonstrate here by adding an additional sensor. So on our PowerPoint guide earlier, we spoke about adding an OS3200 and using a common temperature compensation, which will be our OS4100, and then being to independently zero those. So we can do that now, again through our templates. So create from a definition file. This will be an OS3200 with delta T compensation. And we'll call this our new OS3200. Gauge factor would again be from the data sheet, the CTE, we're putting it in the same place. Our FPG is going to be the fourth one on channel 3, our FPG C4. And we are going to use, notice now we have 3 available temperature sources since we've added our OS4300s, but to demonstrate the independent zeroing, we're going to choose the same sensor that's used for the OS3100, which is our OS4100. Okay? And so now, we zoom in and highlight our OS3200. We see that C4 is its strain sensing FPG, C5 is its temperature sensing FPG, and if we highlight the OS3100, we see that C3 is its strain sensing FPG, and C5 is also its temperature sensing FPG. And so now, notice we have an offset here in this OS3600. That could be due to an offset in strain. Well, it would be due to an offset in strain, and any sort of an offset in temperature would have been tracked by its compensation expression. And now if we want to zero our OS3200, we can do that independently without affecting the value, which is presently around 567 of the OS3100. Okay, so without independent sensor zeroing, if we were actually zeroing one common FPG value for that OS4100, we would have seen a step function in the value of the OS3100. Because it's truly independent, and each sensor element retains its own reference value for each FPG and its expression. Those are truly independent.